The universe is quite huge and extremely bizarre. Many billions of cosmic systems with sextillions of stars and planets, and in everything, there is Earth, with you and us. In any case, as colossal as the universe appears to be looking up, it appears to get significantly bigger when you start peering down. You are overshadowing universes within universes, each on display, and yet hidden from your experience. We should go on an excursion. We'll start in a park, around 1,000 meters long, enough for a brief walk. Each time we click this enchanted button, we'll become 1,000 times smaller. Please slip into this enchanted science suit so you don't pass out and can still see. Are you game? How about we go? Click. The small domain. You are the size of a grain of sand, only 2 millimeters high, standing on a blade of grass that seems as tall as an 8-story building to you. A square meter of grass is now a dense urban area, with 100,000 blades, or 2 Manhattans worth of grass towers. From your new, small perspective, the park that you could quickly walk around before is now the size of France. Crossing it would take at least a week. Human-sized people loom over you, 1,000 times taller than the Empire State Building, their steps tumbling from one horizon to another. A bee the size of a helicopter lands near you, making the ground shake as its furry carapace vibrates with each wing beat. You try to escape but are barely able to move since the air is so gooey. Before you tapped the button, air resistance was barely noticeable, but now that you're 1,000 times smaller, it is as though the air has become 1,000 times denser. It feels like you are traveling through honey. Flying bugs like bees use this to their advantage. Their wings are not made for gliding but like paddles that row through the air. Increased to human size, the bee would outpace a Concorde jet, except it couldn't even take off because it would be too heavy for its wings. Click. The minuscule domain. You've entered the minuscule domain and are now under 2 micrometers tall, about the size of an E. coli bacterium. From your new little perspective, the park you started in is now 1,000,000 kilometers wide to you. If you walked non-stop, it would take almost 25 years to cross it. It's difficult to grasp just how vast the minute world is to its tiny inhabitants. The giant bee that was nearby a second ago is now the size of Mount Everest, towering high into the sky, though alive, buzzing, and vibrating. The air here feels almost solid to you. On the human scale, it would be as gooey as magma, incredibly difficult to push through. The blade of grass now stretches far enough that you can't see its edges, expanding as wide as hairs would to an average-sized human. You see valleys that look like dried-up riverbeds, dead patches like deserts, and giant holes left by ravenous aphids. But if you look carefully, this isn't landscape. These are rows of individual cells, each the size of a house with hard exteriors like glass shells. Every few cells, there are enormous openings called stomata, like mouths, sucking in air and blowing out oxygen. Suddenly, the enormous bee begins to move, a structure made of rigid pieces that slide against one another like a suit of armor. It takes off to escape a drop of water the size of an asteroid, which fell from another blade of grass and is now rushing at you at incredible speeds. You brace yourself, but instead of feeling a solid punch, you just get sucked in. You try to swim, but the water feels thick and sticky, clinging to your limbs like glue. Air particles are loners, while water molecules act more like social creatures that cluster together whenever possible. They pull on each other and create a strong force that traps you. You're still moving, tumbling in all directions, helplessly dragged along by an invisible current. Floating in this tiny lake are tens of thousands of microorganisms. They take on many forms. Viruses the size of tennis balls float around you erratically, and others, like the Euglena oxyurus cells, pass you by like freight trains. Most, though, look like sleek jellyfish the size of a car, sporting long tentacles that act like turbocharged propellers. Despite the water clinging to them like glue, some move many body lengths per second, equivalent to a person scooping through mud at more than 600 kilometers per hour. However, microorganisms weigh next to nothing, and water is so viscous that they basically have no inertia. The result is an odd, jerky motion that's hard to keep track of. Maybe we can learn more about this strange motion if we go even deeper. Click. Atom domain. You've become the size of a molecule, just under 2 nanometers wide. At your new minuscule scale, the droplet now seems as big as the moon to a normal human. The blade of grass it lays on could stretch from the tip of Alaska to the end of Australia, and the park is now almost the size of the solar system, but instead of mostly empty space, it's filled with stuff. Everywhere you look, there are countless molecules and atoms. The rigid walls of the grass cells beneath you are visibly vibrating, undulating with waves of energy. The water droplet contains nearly a sextillion water molecules, all in motion. Water is actually a storm of H2O molecules crashing into each other trillions of times per second. Each of them is moving at speeds of around 2,300 kilometers per hour and bombarding their surroundings mercilessly, sending tiny objects hurtling back and forth. This is the source of the invisible current you saw when you were 1,000 times larger. Scaling this speed to the human level is impossible, as a human-sized molecule would be billions of times faster than the speed of light. This furious motion comes from heat. Heat is a bit abstract at our human scale, where you touch something and get a vague sense of whether it's hot or cold. But down here, you truly feel what heat is, the motion of molecules vibrating, twisting, and crashing as if they're inside a frenzied ball pit. When these particles lose heat, they move more slowly and collide less often. When they gain heat, they speed up and crash together with renewed energy. Temperature is simply the measure of the average speed of these energetic dancers, performing non-stop. Suddenly, a molecule hits you particularly hard, and you are flung out of the water droplet high into the air again. And here you see something shocking, the space between the air molecules, nothing. Between the molecules that make up the air, there is a vacuum. On average, a molecule in the air travels for about 60 nanometers, which is about the length of a hockey rink if it were the size of a human. If we were to pack all the atoms and molecules buzzing around in the room you're watching this in, they would only fill about 0.1% of its volume. 99.9% of the space around you is a vacuum, you just don't see it. Which also means that every time you take a breath, you take in almost nothing with just a few molecules. Click. Subatomic domain. At your size of under 2 picometers, scale starts to lose its meaning. A human would be nearly 2 billion kilometers tall relative to you, so large they could stretch their arms from the Sun to Saturn. A nucleus would be the size of a grain of sand you could hold on the tip of your finger. That grain holds 99.97% of the atom's mass. The rest, an effective reach equally enormous as the Eiffel Tower from your perspective, is filled with an electron cloud. That's essentially all the places where electrons might be at any moment in time. Electrons are shapeshifters that transform around outside a nucleus, creating a new and vibrating mess of different shapes with each passing second. Unlike the smooth motion of planets, the atomic cores are chaotic blurs. They swell, roll, tremble, and relax. They hold back the very energy that powers nuclear bombs, and they don't let them sit still. They twist and vibrate sextillions of times per second. It is time to end our journey and return to. Click. What's happening to you? Click, 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 click. The smallest spot. We have reached the bottom, the line between reality and illusion. The scale here is the Planck length, which is the distance light travels in a Planck time. Planck time is the time it takes light to travel a Planck length. Okay, alright. None of our models of the universe make sense at scales smaller than this, so for now, this is it. Sad click. We think that down here, particles bubble into reality and then spontaneously vanish, creating a quantum foam of unimaginable energy. Can we go even smaller? We don't know. It is time to return. If you look up, the universe is huge and bizarre. So incredibly huge and bizarre. But if you peer down, into the tiny and ultra-tiny, the universe seems even larger and even stranger. In the end, the perfect place might be where you are right now, not too big or small. Thank you for watching. I hope you enjoyed this journey into the mysteries of the universe. If you found this video interesting, please give it a thumbs up and share it with your friends. Don't forget to subscribe to my channel for more amazing updates.